Welcome back to part 2 of linear functions. In this lesson, we will learn how to find the equation of a straight line given a graph. Example 1. Find the equation of a line that passes through a point 0,3 and makes an angle of 150 degrees with a positive axis. So, before you start, you ask yourself, what is it that you're given for you to be able to find the equation of a line? You're given the point, which is 0 and 3, and you can go to your Cartesian plane and already draw that. And you have 0 and 3, and you can see that is your y-intercept. And it also says that the line that you have to find the equation for makes an angle of 150 degrees. So, it passes through that point 0 and 3. So there, I pass through point 0 and 3, and this angle with the positive axis has to be 150. So you're given two things here. You're given the point, and you're also given that it's an angle of 150. What do you do with the angle? You know that your gradient is m equal to tan theta. And from here you can see, I already have the gradient here. And you know, I have a gradient and then I have a point, which is also my intercept. Therefore, I can use the slope to intercept equation, which is y equal to mx plus c. And I have my m as tan theta x plus, and my y-intercept is 3. This is tan theta. Okay, now that we know, let's go and find tan theta. So we go there, we say, it's tan 150 degrees. You can punch this in your calculator, or you can use that, tan theta is equal to 180 minus 30. And this will be minus tan theta because in that quadrant, tan is negative. So this will be tan 30, square root 3. And this is our gradient. Then you have y equal to minus square root 3 over 3. You no longer write tan now. You have y is equal to minus square root 3 over 3 x plus 3, and that is the equation of the line. Example 2, given the graph of f of x with a slope of minus 3 and a point a is minus 2 and 4, write the equation of f of x in the form y equal to. So already they tell you which form they want, which is y equal to mx plus c. And they gave you a slope of minus 3 and a point, which is that. So now you know you have a point and a slope. So you can calculate, you can use y minus y1 equal to m of x minus x1. And then you can change to the form they want. So you have y minus y1 will be 4 equal to, the slope is minus 3 and x minus 2. And you have your equation as minus 3x. That will be positive. So that will be positive 2 times minus 3. That's negative 6. And then you have 4 on this side. And your equation is minus 3x minus 2. And that is the equation of a straight line. Example 3. You're given the graph of g of x. And you are asked to write the equation in the form of y minus y1, and you're given 2 points. So you can write your points down that you have x1, y1 as, you can choose any point to be x1, and in this case, we're going to choose the point A, which is minus 4 and minus 1. And we can choose that x2, y2 is equal to 1 and 5. And now, for us to be able to write it in this point to slope form, we have to find the gradient. And we know that the gradient is y2 minus y1 over x2 minus x1. And y2 is 5 minus y1 is minus 1. and we have x2 as 1, and x2 and x1 is minus 4. And we know this one will be 5 plus 1 is 6. And 1 minus 4 will be 1 plus 4, which is 5. And the gradient is 6 over 5. And now our equation is y minus, we chose y1 to be minus 1. So we have minus 1 here. And then the gradient is 6 over 5. And x1 is minus 4. And our equation will be y plus 1 equal to 6 over 5 into x plus 4. And that is the point to slope form you were asked to find. Example number 4, given the graph of f of x is equal to minus x plus 2. You are told that h of x, which is now a new graph, passes through a point 1 and minus 2 and is parallel to f of x. So you can go to your Cartesian plane and draw the point 1 is to minus 2. So you have 1 and we can say that is minus 2. So we know that it passes through this point and is parallel to f of x. And then we draw a parallel line. So okay, this is not in scale, but we know that is a parallel line. Okay, now we have two things here. We have a point which is a1 and minus 2. And we also have the slope. Why do I say that? The question said this new line, which is h of x, is parallel to f of x. What do we know about the gradient of parallel lines? We know that m of f of x should be equal to m of h of x if these lines are parallel. And we know that m of f of x is minus 1, the coefficient of x. Therefore, the gradient of h of x is equal to minus 1. So already we have two things. We have a point and we have a slope. And we can use the point to slope equation, which is y minus y1 in that form. So we have a point which is minus y1 is minus 2. And the gradient is minus 1. x1 is 1. And you can write it, you can leave it in this form or you can leave it in the form. Oh no, you have to leave it in the form h of x. Because they said they want the equation of h of x. So now you have to convert this. This will be y equal to minus x. Minus 1 times minus 1 is positive 1. You take this on the other side, it will be negative 2. Then you have y equal to minus x minus 1. And that is the equation of h of x. And so you can write it in that form, that h of x is equal to minus x minus 1. And you are done. So that's it for linear functions. We know how to convert an equation to a graph, and we know what to do when we're given a graph and we have to find the equation.